All right, and we should be live. Welcome back. Right, okay. So today we're going to continue on with inline with this the topic we're doing is inline functions and variables. Um, so last time we learnt about global functions, um, global functions, scope, duration, linkage, things like that, and then local script as well. Now today we're going to start off with inline functions and variables. Okay, let me just add the subsection, the subheading. And then we'll do that. Cool. Right. Consider the case where you need to write some following code to perform some discrete task, like reading input from the user or outputting something to a file or calculating a particular value. When implementing your code, you essentially have two options. You can write as part of a code of existing function or create a new function. So okay, so here we have the library of input output stream. We have a return type of integer for min. Min accepts parameters of x and y, both integers. And if x is greater than y, x, else y. So standard character output, min 5, min 6, and then the same for 3, 2. So this will, if x is less than y, return x, so this will return 5, else return y. So if x is less than y, so this will return 5 and 2. So I'm just going to do this, and then this. Okay. Okay. Inline expansion. Compiler has a trick of avoiding where a function call is replaced by the code from the called function's definition. So essentially we've taken 5 and 6 and just replaced it with x and y. Note that the two, so basically what we're doing is we're doing literals, which allow make it easier for the compiler. C++ has avoid overhead costs. This is known as inline expansion. Inline expansion is a process where a function call is replaced by the code from the function's definition, aka the function body. So you're essentially moving you're moving this, or you're basically combining this and this. But the only thing is that creates a lot of line of code. But I guess it's for smaller functions. Yeah. Yeah, so this seems to be for mainly mainly smaller functions. Exactly. If it gets bigger and bigger, then there'll be an issue. So inline expansion is, yeah, as I was thinking, was is best suited for short functions, especially where a single function call can be executed. But to be honest, if you're building larger projects, I don't think inline expansion is useful, in my opinion. Okay. So the inline keyword However, it's no longer used. Do not use the inline keyword. Okay. Avoid the use of unless, yeah. Okay, so we're not going to use the inline keyword. And plus, you can use headers, and as you said there, you can use headers. And remember, headers is if not defined, and then your header name, or no, sorry, your macro header name, then define, then your usually forward declaration, not definition, declaration, then end if. Okay, I'm happy with that. So sharing global constants across multiple file using inline variables. Okay. Um, in some application, certain symbolic constants may be needed to be used throughout your code. This can include physics or maths, such as pi or Avogadro's number, or application tuning values. Instead of redefining these constants in every value, to avoid dry, it's better to declare them in one central location. Okay. And remember, if you want to make if you have a global constant, no, if you have a constant variable and a constant expression variable, the best way to make it global is to use XP. Where was it? Uh, you need to use the keyword of you need to use the keyword of uh, extern. Yeah, extern. So that's the keyword to use if you want to make uh, constant variables global. And if you want to make global variables local or functions local, you would use the word static. Again, go and check out previous lessons and streams for that, or videos for that. Mm. Okay, prior to the create a header file. Inside the header file, define a namespace, add core constants, include the file wherever you need it. Yes. So you would do that. You would, if not define, then all your code here, for example, namespace, and then you can use a scope operator to access in your CPP files. So you're including constants header. You're then including the standard libraries, and then here is where you call constants pi when the header um, yeah, because the globals have internal linkage, each CPP file gets an independent version that a linker can't see. In most cases, these are constant expression. The compiler will simply optimize anyway. Um, yes, so I knew that. Um, so I'm just going to copy that. Uh, no, perhaps not. Would be to turn constants, I would be to turn these constants, constant expressions or constants variables into extern. So then we could just do, so in our so in our constant CPP, we're defining double pi, gravity, and Avogadro. But in our header, we are calling them. Yes, that makes sense. Because the CPP file is where you would typically define things, and the header is where we would simply call them. We use extern to ensure these have external linkage. Yes. Since actual variables are inside the namespace, the forward declaration needs to be inside a namespace as well. Yes. And then we can just do that. Whereas previously, um, the declaration wasn't in a namespace. Yes. Okay. Now the symbolic con will get initiated only once in constant CPP. Instead of each file of code where CH is included, and uses all these constants to be linked to the version instantiated in constant CPP. Any changes will result in only needing to compile this. Yeah, that makes sense. Cool. Um, cool. Um, because the variable definitions are constant expressions, the forward declarations aren't and cannot be. Mm-hmm. Second, because constant expressions can typically be optimized more than runtime expressions, the compiler may not be able to optimize. In order to have variables to be used so you're making them inline, which means that we can define them in the header file and include them in any CPP file that require them. So in our constant header, we're doing if not defined constant h, define constant h, and then we're creating a namespace. Then we're doing inline, and this inline allows us to define it within this namespace. Thus taking out the need for what was the file called? So what was the other CPP file called? Constant CPP. Okay, but that only works for C++ 17 onwards. But it does avoid duplication. This method does not retain the downsides of requiring every file that includes constant headers be recompiled if constant values are changed. Okay. So that is all useful. So what I'm going to do is I'm not going to bother writing it all out, but I will so this one is all about external. And then this is all about using them as internal. So you can use them as, inline. You can use them as internal, external, or inline variables. i.e. global constants. So constant expression functions are implicitly inline, but constant expression variables are not. Okay, static local variables. How are we looking on progressing? Okay. The term static can mean different things in different contexts. In prior lessons, we covered global variables have static duration. We also discussed how static keywords give global identifiers internal linkage. Yes, so this section will be covering the use of the static keyword when applied to a local variable. So, local variables have automatic duration by default, which means they are created by the pointer definition and destroyed when the block or body is existed. Yes. So we know that local variables have automatic duration by default, meaning they are created at point of definition and destroyed when the block / body ends. Yes. Using the keyword static, local variable change duration from automatic to static. So by using the static keyword, our local variables change their duration from automatic to static duration, which essentially means the variable is static, is now created at the start of the program and destroyed at the end, rather than its typical automatic duration, whereby it is created at the start and at the point of definition and destroyed at the end of the block / body. I know I repeat myself a bit there, but I find it useful to do that sometimes. Yeah, okay. So this would be an example of automatic duration. So we'll do include output stream. Then we'll do void increment and print. Then we're creating a local variable for value, initializing it with a 1, automatic duration by default, and then we're increasing the value by 1 with a prefix increment. Then we're providing the standard character output of value with a line break, and the value here. Makes sense. Then in our main function, we simply call increment and print, and we'll do that 3 times. So let me just open my terminal, and then we'll run it. 222. Maybe that's why. No, that makes sense because because we're only increasing it once, despite the fact we're calling it twice, 3 times. So now if we were to use static, assume static here. Yeah, static there. So let me just put that in my notes. Okay, the variable is created. The variable is created at the start of the program, and all I need to do is that. And then we can do the prefix of s for static. And then we run it and we get the result we actually wanted of 234 because it's throughout the body. Okay. So it's been created at the start, and it's 1, and then we're increasing it each time. So by the time we get, so when main is running, we go to increment, it goes to increment print, and it runs line by line. So we then see that this has already been created. This has been created, and now, yeah, 234. I have no initializer or no 0 initialized. So if you did 0, if you didn't put anything initialized, would it be 1, 2, 3? Yes, it would. Okay. AKA if the was not initialized, we would get the output of 1, 2, 3. And then this is always good to make a note of. ID generation. ID generate, one of the most common use static is for unique ID generations, also known as UUIDs, which are, this is short for unique UUIDs, unique something identifiers. Universally unique identifier. Okay. Okay. One of the most common uses for static local variables for unique is for unique ID generators. Imagine a program where you have similar objects, a game where you're being attacked by many zombies, or a simulator where you're displaying many triangles. If you notice a defect, it can be nearly impossible to distinguish the object having a problem. However, if each object is given a unique identifier upon creation, then it can become a lot easier to debug. Yes, okay, so now we're getting into interesting things. Where this can be applied to when you're writing games. Generating a unique ID is very easy to do so with a static. Okay, let's have a look. So let's not just copy, let's practice. Include, spell it correctly. Include, oh, I don't even need that. So we're just going to do int return type of generate ID. Then we're going to do a static int item ID, initialize it with 0. So again, since we're new to static ID, static keyword, we'll make a note. So through by using keyword, by using the static keyword, this local variable is created at the start of the program, not the point of definition, and is only destroyed when the program ends. And then we're simply going to return that with a postfix increment. Which makes a copy of the ID, increments it, then returns the value of the copy. The first time this function is called, it will return 0. The second time, 1. Each time it's called, it returns a higher number. You can assign these numbers because it's a local variable, it cannot be tampered with by other functions. Static variables offer the benefit of global variables. They do not get destroyed while limiting their visibility to block scope. A static local variable has a static variable has a block scope like local variable, but its lifetime is only a lifetime only ends at the end of the program, like a global variable. Okay. Static local constants. Static local variables can be made constants or constant expressions. By creating or initializing an object. If you use a normal local variable, okay, when using, if a normal local variable with a constant expression static local variable, you can create and initialize an expensive object once and reuse it constantly. Don't use static local variables to alter the flow. So we've got the include of input stream as always. We've got a return type integer. And we've got a function that gets integer. So we have a static boolean is first call, and then we're initializing it as true. And then if static variable is true, then we say enter an integer, and then we're setting it to false. Else, enter another integer. So once we've entered an integer, we're setting is first call to false. Then we're creating I. Then we're creating the ability to enter I and returning I. Then in our main function, we're getting integer of A, and then we call an integer of B, and we're calling get integer, and we're producing A plus B equals A plus B. This does what we want it to do, but because we use a static local variable, we made the code harder to understand. If someone reads the code main without reading the implementation, they'd have no reason to assume that the two calls do something different. But the two calls do something different, which is very confusing if the difference is more than a change prompt. Say you press +1 on your microwave and it adds 1 minute to your remaining time. You're warm as meal and you're happy, whilst also being burnt on the outside and cold on the inside. Before you take your meal, your cat is outside the window. The moment turned out to be longer than you expected, and it's cold again, but it's still burnt on the outside somehow. No problem, just put it back in the microwave and press 1, and it'll be even more burnt on the outside and cold on the inside. But this time you add 1 second, not 1 minute. That's when you go, I changed nothing and now it's broken. Or it worked last time. Surely, can we use inline, maybe? Get integer is not reusable because it has an internal state. Yes. Which cannot be reset from the outside. S integer is not a variable that should be unique to the entire program. Although the program worked the first time we wrote it, the static local variable prevents us from reusing the function later on. One better way of implementing getInteger is to pass this as a parameter. This allows the user to call. This allows the caller to choose which prompt to be printed. So we'll define with a nice name, constant expression, Boolean get first call is true, and then we're creating a local variable. If B first call is true, then enter an integer, else enter another. Non-constant static local variables should only be used if your entire program and the foreseeable path of your program, the variable is unique and won't make sense to reset. Okay. What effect does using keyword static have on a global variable? And what effect does it have on a local variable? On a local variable, it changes the duration, i.e., it's defined at the start of the program and ends at the end of the program. And on global, have internal linkage, meaning the value cannot be used in other files. Yes. Okay. We'll just make a note of that. Okay. Scope duration and linkage summary. So are we nearly finished then? Yeah, almost. Scope duration and linkage summary. So I want to make a note of this. Okay, so scope summary. An identifier scope determines where the identifier can be accessed within the source code. And remember, this is the identifier. This is the data type, and this is the type of variable. Where the identifier can be accessed within the source code. Variables with local scope can only be accessed at point of declaration until the end of the block in which they're declared. Yes, that makes sense. Variables with global scope can be accessed from the point of declaration until the end of the file. This includes global variables, functions, and program-defined definitions such as enums and classes inside a namespace, or inside a namespace or in the global scope. Okay, scope summary, now duration summary. A variable's duration determines when it is created and destroyed. And sorry about that, that was annoying. Maybe that's better. So as we learn, variables have automatic duration or default dynamic duration and static duration. Variables with automatic duration are created at the point of definition and destroyed at the part they are exited. Variables with static duration are created at the start of the program and end of the program. Yes. That makes sense to me. And variables with dynamic duration are created and destroyed by programmer requests. This includes dynamic allocated variables. Linkage summary. An identifier's linkage determines whether the declaration of that same identifier in a different scope refers to the same entity, i.e. the object, function, reference, etc., or not. Local variables have no linkage. Each declaration of an identifier with no linkage refers to a unique object of a function. An identifier with no linkage means another duration of the same identifier refers to a unique entity. Entities whose identifiers have no linkage include local variables and program-defined identifiers declared inside a block. So you've got scope, duration, and linkage. An identifier with internal linkage. So you've got no linkage, internal linkage, and external linkage. Just like you have automatic duration, static duration, and dynamic duration, and scope of local and global. Okay, starting to get the hang of it a bit, he says. An identifier with internal linkage means declaration of the same identifier within the same translation unit refers to the same object or function. Entities whose identifiers have external linkage include static global variables, initialized or uninitialized, static functions, constant global variables, and unnamed namespaces with anything defining them. Okay. Then identifier with external linkage means the declaration of the same identifier within the entire program refers to the same object or function. Entities whose identifiers have external linkage include non-static functions, non-constant global variables, as we learnt, external with the extern keyword, constant global variables, inline global variables, and name spaces. Identifiers with external linkage will generally cause a duplicate definition link error if the definitions are compiled into more than one CPP file. There are some exceptions to this rule for types, templates, inline functions, and variables. Also note that functions have external linkage by default. They can be made internal by using static. Yes. Okay, that seems very useful. So I'm probably gonna take a note or take a screenshot of that rather than make a note because I think the screenshot would be cleaner. Forward declaration summary. You can use forward declarations to access functions from another file. The scope of the declared variable is usually good. Is as per usual. Global scope for globals, block scope for locals. And again, I'm probably going to take that because it would be easier. When users apart, the static and external keywords are storage class specifiers. In this context, they set the storage duration of identifier. So you got extern, static, thread local, which we haven't done, mutable, object allowed to be modified, even if containing class is const. Okay. Automatic summary duration, but that's been deprecated, and register, automatic storage duration to hint the compiler, but that's been deprecated. The term storage class specifier is only used in formal documentation. Okay. No, don't want that. That one. Okay. Okay, I'm going to take a quick break here. And I'll be back in a minute. All right. Okay, and we're back. How are we looking on the stream? Good, all good. Okay, nice. Okay, cominciamo. All right, where were we? Using declarations and using directives. You've seen a lot in this program. You've probably seen this program a lot in textbooks. The standard hello world. With using namespace std. Short history lesson. Before C++. Small. In 1995, namespaces were standardized. Updating every name that now has moved to SE name. A solution was requested. Fast forward to today. If you're still using the standard library, in order typing std before everything, in some case make cargo read and read. C++ provides solution to both these problems in the form of using statements. But first, let's define two terms. Either qualified and unqualified. A name can be qualified or unqualified. A qualified name is a name that includes an associated type. Most often, names are qualified with namespace using the scope resolution operator. Using definitions and directives. Declarations, not definitions. Qualified and unqualified. Okay. So a qualified name is a name that includes an associated scope. For example, standard character output qualifier name std. Yes, we've dealt with these previously. Okay. An unqualified name is a name that does not include a scoping qualifier. For example, character out and X are unqualified name as they do not include an associated scope. Using declaration. Using declarations. One way to reduce repetition of typing standard over and over is to utilize a using declaration statement. A using declaration allows us to use an unqualified name within a scope for as an alias for and as an alias for a qualified name. Here's our basic hello program world using using a using declaration on line 5. So this using declaration tells the compiler that count should be resolve standard character output. But you're still having to type out this though, aren't you? Which, yeah. But then you're doing that twice. The using declaration is an active point of declaration at the end of the scope. Yeah, I mean, you're still essentially doing the same exact thing, aren't you, though? Surely it's the same thing. Um, but you're just doing more lines of code, and you're even though it says no std prefix is needed here, you're still here. You're still having to type in the prefix. Um, that's using definition, using directives. Using directives allow unqualified access to all names and unqualified. It's that. This risks two factors. Um, yeah, true. Because you got X here and X here. So what is actually printing here? Here's another example, character output, and even though we're using namespace, character output, which one does it mean? Does it mean within std, or does it mean within here? Exactly, because you've declared the function of um, cout, but then you also have here you're using the namespace cout, but then you're also doing character output. And is it referring to the standard or is it referring to the function? You're doing 5 in exertion operator hello world, which doesn't make sense. Yeah, the same thing for libraries as well. I can see that. Um, so are we? Uh, yeah, so you got foo lib h, some third library, and it's doing this, and then we're calling it here, and then we're creating our own get long integer, get long get with a long parameter and returning one, and then we're using namespace of foo, which is this because we're calling it via this, and then a, which is in there, and get. Yeah, I can see why that's would create an issue. The compiler encounters a function call in, in selecting a function from a set of matching functions. We prefer a function that requires no argument conversions over a function that requires argument conversions. Because the literal zero is an integer, um, C++ will prefer print zero to match print zero with a new print int, i.e. this one. Where were we? Yeah, when printing zero in your result. Yeah, yeah, true. Using with the without the user directive is much clearer because we're using the scope identifier, um, and then we're going foo, i.e. within namespace there is a function called foo, and this foo is likely someone else, somewhere else. Scope identifier, yeah, scope identifier. Okay. So a good rule of thumb is that using statements um, should not be placed anywhere where they have an impact on the code or a different file, nor should they be placed anywhere where the file's code might be able to impact them, nor before include directive. For example, if you placed a using statement in a global namespace header file, then every other file would also, yeah, true, that's bad. But what about using statements? So do not use using statements in header files or before include directives. So you got namespace foo with a void return type function of print with a parameter of integer, and we print that. And in namespace double header, we have that. Yeah. Mm-hmm. Yeah, put it in nested blocks. Okay. Okay. Unnamed and named line spaces. Inline namespaces. We obviously learned that inline namespaces can allow for constant and constant expressions to become local variables rather than global. So, unnamed or anonymous namespaces. Okay. An unnamed namespace is a namespace that is defined without a name. That is defined without a name, such as namespace, and usually we'd have a name here, and then we have some function in here. We can call do something without a namespace. Oh, okay. Okay. All content declared in a unnamed namespace is treated as part of the parent namespace. So even though the function is within that, okay, it might make namespace. This might make seem useless, but the other effect of unnamed namespaces is that all identifiers in an unnamed namespace are treated like they have internal linkage. Okay, which means that the content of an unnamed namespace cannot be seen outside the file. But that could also lead to potential naming issues, no? For functions, as it's easier to cluster such content in a single. Using, no, yeah, unnamed namespaces will also keep. Okay. Prefer unnamed namespaces when you have content you want to keep in a local translation unit. Avoid namespaces in header files. So inline namespaces. So you got input output stream library in the header. We got a return type of void for do something, and then we have standard character output of v1 with a line break. Then we're calling do something. But let's say you're not happy with do something. So consider this. So we could use an inline namespace. An inline namespace is a namespace that's typically used to version content. A namespace, an inline namespace is a namespace that is typically used to version content. Much like an unnamed namespace, anything declared within the inline is considered part of the parent namespace. However, unlike unnamed namespaces, inline namespaces don't affect linkage. So to make a namespace inline, we simply use the inline keyword. So that declares it as inline. So I want to copy that or do it myself because I think it'll be the best way. So input output. So inline name space version 1. Declare inline name space named v1. And we have void do something, and then we're doing a standard character output of v1 with a line break. Then we have a normal namespace of version 2, declaring a normal namespace, and then again we're going to have the void of do something, and then we're going to print v2, and then in our main function we will have a return type of integer, and we're going to use the scope operator, v1 do something, and then we're going to do v2 with a scope identifier of do something again. Then we're going to call do something, and you can see here, I don't know if you can see, you might have to zoom in on the stream or the video. You can see here we have void v1 do something. So we're not even using the v1 prefix and the scope operator, and we're already getting the ability to call it because we made it inline. So if we did that, we would see where what are we actually referring to, which is very helpful. So if we press that and then we run the code, let me just clear my terminal. I got v1, v2, v1. Cool. Such as nice. Okay, so I need to put my laptop on charge actually. Let me just do that. And then as you can see here, alternatively, if we changed this from we removed inline here and we replaced it with here, do something here would become v2 because we're using inline. makes sense. Cool. Okay. Right. Summary. We've covered quite a lot of this, so I think I'm actually gonna. No, I'm not gonna make a note of this, but I probably will make a note of the quiz if I struggle. Um, so a compound statement or a block is a group of zero or more statements that is treated by the compiler as if it were a single statement, i.e. within the squiggly brackets of, for example, a function. Blocks can be used anywhere in a single statement is allowed. No semicolon is needed at the end of the block, which you might get sometimes in other languages. Blocks are often used in conjunction with if statements to execute multiple statements. Cool. User-defined namespaces are namespaces that are defined by you for your own declarations. Namespaces provided by C++ or by libraries are not considered user-defined. You can use a scope resolution operator. The scope resolution operator tells the compiler that the identifier specified on the right hand, i.e. the right, should be looked at in the scope of the left hand operator. If no left hand operator is provided, it is assumed that it's global. Yes. Local variables are defined within a function. Local variables have block scope, meaning they are defined at the point of definition and destroyed when the block ends. Local variables have automatic, meaning they're created have a block scope, meaning they are in scope. They are in scope from definition until the end. And local variables have duration, automatic scope duration, meaning they are created at point of definition and destroyed in the block they are defined. I accidentally clicked a ad. Hopefully I won't. Oh no, nothing happened. Am I still good? Nothing's. Yeah, cool. A name declared in a nested block can be shadowed, yes. Yes, so if you declare a local variable and then in a nested block you declare it again, the one declared above the nested block is then hidden in place of the new variable inside the nested block. Global variables are variables defined outside of a function. Yep. Yeah, this should be avoided for shadowing, but it's good to know. Global variables have file scope, which means they are visible at the point of declaration until the end of the file. Global variables have static duration, and static duration means that they are created when the program starts and destroyed when the program ends. Cool. Avoid dynamic initialization wherever possible. And identifies linkage determines whether the other declarations of that name refer to the same object or not. Local variables have no linkage. Identifiers with internal linkage can be used within a single file but cannot be accessed with other files. Identifier with internal linkage can be used from a file in which they are defined and other coding files. Avoid non-const global variables wherever possible. Use inline variables for global constants. Local variables can be given this static keyword, and so can functions. A qualified name is a name that is associated with scope. An unqualified name is the opposite. Using statements, including using declaration, can be used to avoid having to qualify identifiers with an explicit namespace. Using declaration allows us to use unqualified name with no scope as an alias for qualified name. A using directive imports all the identifiers from the namespace of the scope using directive. Both of these should generally be avoided. Inline expansion is where the function is replaced by the code from the called function, such as what we saw with this here. A function that is declared using an inline keyword is called an inline function. Inline functions are variables that have two primary requirements that we've learned. Inline functions and variables are particularly useful for header-only libraries. And then finally, C supports unnamed namespaces and also inline namespaces. Okay, quiz time. I'm just going to take a break here and I'll be back in a minute. Okay, and we're back. All good on the audio. Just double checking. Yeah, okay. Let's continue then. So, quiz time. Fix the following program. So, uh, the best way to probably do it is to practice or to write it out myself and then see the issue. Ah, no, I've just realised the issue now. Um, so I'm just gonna still gonna copy out exactly how he's done it. Negative number entered, making uh, positive. I've just realised what he's done, and then num equals minus num, and then standard character output you entered, and then num, and then we'll, as always, return 0. So the first thing I would personally do is because our if statement has more than 2 lines, we will actually need to um, add brackets to it. So that's the first thing I'm going to do. I'm going to add bracket there, and then add a closing bracket there. That way it should run. The second thing I'm going to do is I'm going to just add a line break here. I'll do a full stop and then a line break. So that's the first thing I'll do. Let's just see how that runs now. Let me just clear my terminal. Enter a number. We'll do minus 10. You entered 10. Entered spelled correctly, hopefully. Entered N. No, it's. So is that all that we could do? Because if we got rid of the brackets, let's see what issue we'd have. Oh, I guess it's within the scope. Um, oh, okay. So that was literally anything. No, I don't want to save that. I wanted to save my my question. So that was fairly straightforward, I thought. Um, Okay, next question. Write a file named constant height that makes the following program run. Use an inline constant expression variable, otherwise. Okay, question 2. So our current main is this include input output stream, but what we actually want is we want to also include a constant header, which I'll comment out for now to avoid any errors. And we'll do a return type integer for our main function, and then we will do standard character output. How many students are in your class? We'll create the students, then we'll do standard character input, of students, allowing the user to enter. So what I'll do first is I'll create an if0 block and then an end if, just to comment it out for now. So we'll do if, and I'll just, so it's easy to get rid of and easy to see. If students is greater than constants max class size, then we will do standard character output. There are too many students in this class. Then we'll do else, and we'll do this class isn't too large, and then we'll return 0. Now I think I already have a constant no, I don't. So why is that? So what I'll do anyway now is I will so I'll create a constant header. That's already okay. Constant header. Yeah. So we know that the template for constants for headers is if not defined, then we defined what should we name it? We'll name it constant head. Constant header. Then we will, if it's not defined, we will define constant header. Then our code will go here. And then what we'll do is we'll end if. So, since we're on C++ 17 or higher, we can use a inline constant expression variable. So we'll be able to define or made a forward declaration here. So we want to make a max class size. So if we do inline constant expression max class size, and say we make our class size max class size of 30. We're getting an error here. Oh, because we need an integer, that's right. So, inline in the file to be able to use this in the main CPP file. And because we are using inline, this means we can actually define this variable in the header rather than making a separate file for the definition and then calling it in this header. I think that's right. So then we go back, close that. Then we go back to this. We can get rid of this. And then we can uncomment this. And we can actually... No. I realized what I just did wrong. I'll put that back. This actually needs to be in a namespace, surely. No, hang on. Yeah, no, it does need to be in a namespace. So not using. So namespace constants. And then we'll close that. We'll indent that to make it easier. Then if we get rid of that, oh, that's, no, get rid of inline. The reason why we're throwing a hissy fit is because of that. Yes. And we're getting an error here because I forgot the semicolon. Okay. Why are we getting an error there? No, we're fine. So I believe that is good. So we've defined our max class size as that with an inline constant expression. And then remember an inline allows us where is it there? An inline is where a function call is replaced from the code of that function's declaration, i.e. all of this, I think. A function that is declared using inline keyword is an inline function. Inline functions, so inline variables, which are variables that are allowed to be defined in multiple files. So I believe if we run this, if we clear the terminal first, if we run this, how many students are in your class? Let's do 20. This class isn't too large, and I just want to add a line break to both of them. I don't know whether he did it in his example. No, he didn't. I just want to make it easier. So 20, and then if we did 31, this class, there are too many students in this class. Okay, so let's see if that is the correct way to do it. Name constant, inline, constant expression, and then remove inline keyword if not C++17. But we are, or I am C++26, I think, so I'm all good. And then that remains unchanged. Cool. So next, write a function inc accumulate. This function should return the sum of x values that have been passed into the function. So what I want to do first is I want to um, okay. Um, Question 3. Write an int accumulate. This function should return the sum of all the values that have been passed into the function. So we'll just write out what we have at the moment. Include input output stream, return type of integer, main, and I'm going to just comment out the code at the moment. Standard capture output, accumulate, that would be 4, and then a line break, and then I'm just going to copy and paste those and replace them with numbers. So 4, 3, 2, 1, and then this will obviously return our 0. So 4, 3, 2, 1. So we want a int use a static local variable to store the sum. So a static local variable. No, I want more towards the end. I want examples. So we'll be doing something like that. So static, so if we did static sum, and then we did x, and then we would increase the value. But would we use prefix or postfix? We'll use postfix because we want to make a copy. Is that right? So sum and then postfix, and then we're gonna do then we're gonna do that. This. Well, that doesn't really feel right. Make it void, perhaps. I don't think that is actual good code, but I just want to see what would happen. And then we'll want to return sum. Static int. What would happen if we ran this code just out of curiosity? Okay. No. So we're getting. So I don't think we need post, we need prefix. So we'll clear the terminal. And we still get 55. But that's not right because that should be 4, that should be 7, that should be 9, and that should be 10. So I'm doing something wrong here. Maybe because we're doing that. No, 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 no. No, 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 I think I know why. We want to start from 0 because if we initialize, it starts with 1. So, but then where are we calling? We're not calling x anywhere. No, we're calling x here. So if we've already cleared the terminal. So if we ran the code, okay, we're getting closer. We get, if we did 0, okay, so we're on the right direction. So I think standard character output, what if we got rid of this? And then cleared our terminal and we ran it. Okay, we get 1, 2, 3, 4. So we're not actually. This should print 4. But it's printing 1. So if we added x back, we would get 5, 6, 7, 8. So does this mean we need to set that to 0? But then if it's 0, we get that. What if we set it to 1? We get 2, 3, 4, 5. So we do this. No. What if we did do postfix? No, we still want. Um, I don't think that would work. No. No. Let me return that. Return that. So you got static x. I mean, surely we need to use like a for loop. We haven't covered for loops. So you do static let to store the sum, and we are, and we're adding the sum, and then we're returning the sum, and accumulate is int x. Unless we did. No, I think I'm going to have to look at the answer. Plus equals. But, okay, so it's supposed to be 0. Plus equals x, yeah. Okay. Because you're adding 1 as you go along. You're not increment. No, that makes sense now. So we don't use the prefix or postfix, as this would only increase the value by 1. We would be better off using the plus operator, as this would increase as needed. So yes, that does make sense. That makes sense as well, but I should have realized. So sum plus equals x. And we clear the terminal, which means then we need to get rid of this because we're duplicating it. And then we get 4, 7, 9, 10. Cool, nice. Okay. What are 2 shortcomings of this? So let's try and do that as well. No, I don't know the shortcomings, to be honest. There's no conventional way to reset accumulation without restarting the program. The conventional way, there is no conventional way to having multiple accumulators running. Okay. So I want to make this an example. So and I'm going to leave the comments. So we don't need this as we are using when in main and calling the function. Okay. Okay. Nice. So, where were we? So, that is chapter 7 done. Scope and duration and linkage done. Pretty theory based. So that's why I struggled with it a bit, to be honest. Day 14, part 1. Now we're getting on to the interesting things like control flow and if statements. So what did we do today? We did inline functions and variables. We did inline expansion. We did sharing global variables. Sharing global constants across multiple files. Global constants as internal variables. Within a namespace. And then global constants as external variables. Then the namespace again. Sorry, external, external. Using extern keyword. And then we did global constants as inline using inline keyword. Then we did static local variables. Using the static keyword and placing them in namespaces. We did a little bit about ID. Using flies, man, they come in so easily, and then you can't. They act like they have all these eyes, and then they can't actually get out of the fly out of the window when you want them to. Get out of here. And then they hide behind the plants. They hide behind the plants, and then they act like they don't know how to get out. It's ridiculous. Anyway, um, right, where were we? Using static duration variables uh, for ID generation. Static local constants. And then we finished off with the summary. Then we did using declarations and directives. And we did qualified and unqualified. And then that was it. Okay, tutto bene. And today's date is the 12th. Commit. Cool. So where are we on the time? Okay, so we'll probably go for another half an hour. Now we're getting on to the more exciting things. So like control flow, then we'll do error handling, then we'll do type conversion, and then we get into things like references, enums, and structs and classes. Cool. Then we get into vectors and algorithms and all that interesting stuff. And then we'll be done, he says, as there are a lot more. But essentially it seems like they're just going into more detail. Then we'll be able to create interesting projects. So I'm going to just take a quick break now, and I'll be back in a minute to start on control flow. Okay, and we're back. How are we looking on the stream? Yeah, all good. Okay. Um, okay, so control flow. So now we're doing chapter 12 in my notes, control flow. So, cool. So what's the time? Time is okay, so we'll probably go for another half an hour, I'd say, and then we'll see where we are. Okay, so begins. I think this will be a lot more exciting than uh, the previous scope, duration, and linkage. But still, scope, duration, and linkage is interesting to know and important to know because that is essentially what combines your whole program together. So, anyway, control flow introduction. So, as we know, when a program runs, it's run from main and it essentially runs line by line or statement by statement, which is could be line by line. Um, so let's just copy that. Consider the following program. Standard character output, enter an integer. We create the integer. We then allow the user to enter, and then we provide an output. So, categories of control, a flow control statement. I will take a screenshot of that, but I think also add it to the notes. Categories of flow control statements. Okay, so category meaning. Okay, so category statements causes, and I want to do that. So meaning, and then if else, jumps, no, conditional statements, yeah, no, jumps is that, and go to break, function calls, and then function calls return, loops repeatedly executed in code, like for loops, Um, no, I thought I could, but I can go to, and then while, and then halts, terminate the program, standard exit, STD abort. A special expectations with throw, try, throw, and catch. Cool. And when I obviously minimize this window, it'll look a bit weird, but I just want to make sure when I'm looking at it without that in the future, it's all nice and lined up. Uh, so I'll just do that, and then we'll be looking at into in the future. So now we get to go to if statements and blocks. As we've already covered, you should know what an if statement is. If you don't, feel free to have a quick look at the recap. Or feel free to look at previous streams, or feel free to look at previous lessons where he's gone into if statements and also conditional operators, which are essentially a short version of an if-else statement. So the first category of control is we're going to be doing is a conditional statement. Okay. The most kind of basic is this, and then else. But you can also have else if as well. And then if this is true, if the condition is true, then this runs, else this will run. Yeah. Here is a program. So here, for example, we are doing return type of integer for our main function. We're asking the user to enter a number. We're providing or creating, initializing it as empty. Then we're allowing the user to enter. And if they enter a number greater than 10, your number is greater than 10, else it's not greater than 10. If or else with multiple condition statements. So here we've got a namespace of constants with a constant expression integer of min right height 140. Enter your height. We do the we create the variable. We allow the user to enter, and then if x is greater than or equal to constants, you are tall enough. Else you are not. Too bad. The best way to do that is to actually remove this out of the else statement. The program doesn't work as expected because the true statement and false statement can only be a single statement. The indentation is deceiving us here, and the program executes as the above program executes as if it had been written like this. So if you are tall enough, but you too bad will be written. So we will need to remove this out of the else block. No, sorry, that is completely wrong. Ignore what I just said. My bad. I should have realized what I said when I said it. So it should have been, it's the correct statement, but you need the blocks here. My bad. Ignore what I said previously. Remember that blocks are treated as a single statement, so now it works. Yeah. If the program does not declare box statements in an if statement, especially if you have multiple lines. So ignore what I said previously. Do not move it out of the else statement. Move it back in, but put blocks. Okay. And then it's better to write it like this. Yeah, because we learned all about scope, definition, and linkage a few minutes ago. Now it's created, X is created here and destroyed here, X is created here and destroyed here. Cool. To block or not to block single statements. So in many languages, I say many, the ones I've used, including C++, C++, Swift, JavaScript, Node.js, for example, and there's probably one or two others, Python, forgetting. If you are on a single line, you typically don't need a bracket for your if statements. And personally, if I have a single line, I don't use it. But if you'd like to use brackets to make it more readable for yourself, feel free to use it. I mean, it's your programs, it's your prerogative, really. You can do whatever you want to do. So, for example, here you could put it in bracket. Um, so purchase beer. So even though this, so checkout is out of range, from what I can tell. It still looks like it could potentially be an if, but I don't think it would be. Um, so probably the best way to do that would be to put this in brackets, maybe move it a line up, and that'll make it more uh, reasonable to read. Yes, this is very often the case. To avoid, um, mhm. You could also potentially, um, no, no, no. I was going to say use and. Um, what if you did do A and B and C, and then you did A and then a new line, B and then new line, C and then new line. Sorry about that. That is annoying. That's too annoying. Um, okay. I'm skipping over this because famous last words. I'm fairly comfortable with if statements. Let's just make one note there. Cool. Common if statement problems. No, I'm not interested in that. So, nested if statements and a dangling else problem. It is possible to nest if statements within other if statements. So if, again, enter a number, integer, allow the user to enter said integer. If x is greater than or equal to 0, and if x is less than or equal to 20, it's somewhere between 0 and 20. Yeah, and then else x is a negative number. I assume that looks like it belongs to this one, the outer, because the else for this would be here, I assume. Well, it does look difficult to read. Yeah. Yeah, so surely it should be, this should be outside of this body here. Yeah. Flattening nested if statements. So for example, again, we still have the enter the name number, sorry. So if x is less than 0, x is negative. Else if x is greater than or equal to 20, x is between 0 and 20. Else x is greater than 20. Then again, enter another integer. So if x is greater than 0 and y is greater than 0, then we're using the logical and operators to see if they're both true. Both numbers are positive. If x is greater than 0 or y is greater than 0, using the OR operator, one of the numbers is positive, else neither is positive. Cool, that makes sense. Null statements. Null statements is an expression that just consists of a semicolon. They do nothing. I assume we'll be covering pass later on, so I'll skip over that for now. Inside operator your equals operator versus make it equal to. So this is exactly equal to, and this is equatable, I assume, for equality and assignment. Yes. So operator versus operator V is for testing equality if something is the same as another and then V is testing or is for assignment. So enter enter 1 or 0, int int variable unassigned, allowing the user to enter if x is equal to 0. So we've actually used the assignment operator here. You entered 0, else here. So that should actually be double equals, because you're wanting to make it equal to. Yeah. So even if you entered 0, it would still say entered 1. Yes. Constant expression statements. I think we will leave it for now at constant expression statements. There wasn't a quiz there, was there? No, there wasn't. Okay, cool. So we're here, constant expression statements. So let me just say this, left off at lesson 8.4, const expression if statements. Okay, let's update our, so day 14, part 2, and we covered briefly control flow, the various categories of control flow statements, and then we did if statements and the various errors that can occur. That was it, wasn't it? Yeah, it was. So tutto bene, and it is the 12th today. Cool, nice. Let me save that. Yeah, and let me just open that so when I open it, it'll open. Okay, we'll get rid of that. Get rid of that. We'll save that. Yeah, so that was it for today. A lot on scope, duration, and linkage. Hopefully, it's more clear to you now. If it wasn't, it's certainly a lot more clearer to me. But I'll probably end up forgetting it and needing to go over it again. But anyway, that's for another another day when I realise I haven't actually learned it. So yeah, that's it for now. Hope if you've been following along, hopefully you're enjoying it as much as I am, um, and all that kind of stuff. If you are following along and you'd like me to do something else, or you, in terms of syntax or semantics, let me know. If you are following along and you think I did something well or I can do something else better, definitely let me know. And yeah, hopefully you're enjoying it. It seems like we're going to get more um, into more interesting stuff later on, like especially with classes and structs, and more into functions. It seems now that the theory is sort of gone for now, and we're actually going to do more practical, even though we're still going to be learning. But yeah, if you enjoy the video, let me know. Leave a like, comment, subscribe, all that good stuff, and I'll see you in the next one.